Hello everyone, welcome to shiwam'sclasses. In today's lecture, we are going to discuss problem number 1 to 4 of exercise 3.4 from chapter number 3, and that is from the standard level mathematics. Alright. So, in my previous videos, we have concluded our 3.3 exercise. In today's lecture, we start with problem number 1, and just like any other video, first we'll try to understand the concept behind this problem and then try to solve this problem. Alright. So, first of all, we need to understand 2 or 3 things. When we are asked to give a principal solution, principal solutions are basically all the angles between. Principal solutions will have theta between or x between 0 to 2 pi. And then general solution will have something. General solutions will have something in terms of n, alright, where n is an element of z, right? And then there are quite a few, not quite a few, but there are 2-3 concepts here. Actually, there are 3 theorems which we have studied. So, first of the very first theorem is this: sin x, if sin x equals to sin y, then in terms of general solution, x will become n pi plus minus 1 to the power n y. This will be my general solution if my sin x is equals to sin y. Alright. And the next one is when cos x equals to cos y. When cos x equals to cos y, then my x will become 2n pi plus minus y. And the third one is when my tan x is equals to tan y. In that case, what will happen is my x will become n pi plus y. Correct? So, if we remember this, then our job will be little easier. If not, then also we will be able to actually conclude the general solution given our principal solution. So, let's try to remember these. If not, then still I will show you how do you get to a general solution given that you have been able to find the principal solution. Alright. Alright. So now since we have done this, we are going to start with our problem. Alright. Now let's start with our first problem of the day, and we have been given this, that tan x equals to root 3. Alright. So let's remember, wherever tan is positive, and then what would be that value? So if we go to our system, Cartesian system, we know that everything is positive here, then only sine and basically cosec is positive over here, then tan is positive over here, and then cot is positive over here. So given this tan x equals to root 3, my x would lie in first quadrant and third quadrant, right? So what would be my first value? We know that tan x equals to tan of pi by 6. This is one of the values. Pi by 3, 60 degree, right? This is one of the values. Or what if I just add pi to it? So the next value will be tan of pi plus pi by 3, right? So tan of pi plus pi by 3 will be tan pi by 3. And what is pi plus pi by 3? My pi plus pi by 3 is nothing but 4 pi by 3. Alright. So now my x is actually going to be in general solutions, principal solutions term, x will be equal to pi by 3 and 4 pi by 3. Alright. Now given here, we have just studied that if tan x equals to tan pi, then in terms of principal solution, x will be what? X will be equals to n pi plus y. Alright. So it will be n pi plus pi by 3, where n is an element of z. So n will take any value from minus infinity to plus infinity, minus 1, minus 2, minus 3, all that will be included. Alright. So let's say you come here and then you don't remember this, right? What will be my general solution? So let's see if we can work with this itself. What I had done, here you can see the one part was pi by 3, right? One part was pi by 3, and next one when I was trying to do, I was doing tan pi plus pi by 3. So when you write it, the first one you can write it as 0 plus pi by 3, right? And second one you can write it as pi plus pi by 3. And we know that our values repeat after every pi. So next one will be 2 pi plus pi by 3, and so on and so forth. So this is my first one, 0 plus pi by 3. This is my second one, 4 pi by 3. And then third one is this, gonna be 7 pi by 3, or so on and so forth. But here you see this, first one is 0, second one is pi, third one is 2 pi. So can I write it like n pi plus pi by 3, at least here, where n equals to 0, 1 and 2, and so on and so forth. So actually we can go on like this, and this will be true even for the negative values, and that is why you get this general solution. This is your general solution, and this is your principal solution. So principal solution is basically between 0 to 2 pi, and that's what we got. And the second one, as I said, we are going to get like this, x equals to n pi plus y, which is a general solution. Alright, so the first one we are done with. Now let's take the next one, which is sec x equals to 2. So let's go to the next page and put my sec x equals to 2. Alright, again let's figure out where all this sec x will be positive. So sec x is nothing but it's 1 upon cos x. So it will be positive here in first quadrant, and then here, right? For first and fourth it will be positive. So my values of sec x would be, first of all, if you remember what is gonna be your sec theta, if you know your cos theta. So if sec x equals to 2, then what will be your value in terms of angle? So we know that cos of pi by pi by 3 is a 1 by 2, right? So sec of pi by 3 would be 2. If you remember, that's good. I generally remember with cos, and then I try to do a reciprocal. So yeah, so this is gonna be your one is gonna be sec x equals to sec of pi by 3, and then the next one would be, here it is pi by 3 basically, and then the next one would be, you have to come to the fourth quadrant. So basically you have to do nothing but 2 pi minus pi by 3 to get to the other one, which is nothing but sec of 2 pi minus pi by 3, right? And it would be, when you just calculate 2 pi minus pi by 3, what will you get? 2 pi minus pi by 3, you will get 5 pi by 3, right? So your x is gonna be pi by 3 comma 5 pi by 3, right? This is gonna be your principal solution. Now in the previous slide which we had shown, if you know the principal solution, you can just arrive at the general solution, which has been nothing but 2n pi plus minus pi by 3, right? Alright, and now this is gonna be your principal solution where n is the element of z. Alright, and so this is your general solution. Okay, so you might be wondering, why do we take pi by 3 and not 5 pi by 3, right? So the let's say if you want to write 5 pi by 3, what you will write 5 pi by 3 as? You will be writing 5 pi by 3 is nothing but 2 pi minus pi by 3, right? And as you can see, this is included here. When n becomes 1, basically when n becomes 1, then this will become 2n pi, this will become 2 pi plus minus pi by 3, right? So one of the things will be 2 pi minus pi by 3 as well, right? 2 pi minus pi by 3, sorry, it will be 2 pi minus pi by 3 as well, which is nothing but 5 pi by 3, right? So 5 pi by 3 is already included in this one. So that is why we just take the first one, which is the first quadrant, and then use it like this, and then we arrive at the general solution. Alright. So let's take the third one. The third one is cot x equals to minus root 3. Cot x equals to minus root 3. Alright. Again, where all my cot would be negative, so cot would be negative here and cot would be negative over here. So this is my gonna be second quadrant and fourth quadrant, right? So we'll write cot x equals to, and the first value where it will be negative. So first of all, we need to remember what will be my value of cot, for which it is root 3. So when cot x equals to root 3, what would be my value? So my value would be cot of 30 degree, basically, so pi by 6. So when I have to get the value in the second quadrant, what I will do is I will put first one is cot of pi minus pi by 6, and the fourth quadrant I will put cot of pi 2 pi minus pi by 6, right? So when you solve it, you will get cot of pi minus pi by 6 equals to cot of pi by 6 with a negative sign. Same way, cot of 2 pi minus pi by 6 will be minus cot of pi by 6, and then that will be the value. So solve it, and then you will get x equals to 6 pi minus pi. Basically I am subtracting it, so I will get 5 pi by 6 over there, and then 6 2 are 12 minus pi, so I will get 11 pi by 6 over here. So I got the value 5 pi by 6 and 11 pi by 6 as my general solutions. Alright, and now coming to the principal solution, just like my tan x, my x would be n pi plus y, and in this case y is 5 pi by 6, so n pi plus 5 pi by 6, where n is element of z. So this is my general solution. Sorry, yeah, this is gonna be my general solution. Earlier one was my principal solution, right? Earlier one was my principal solution. Okay, this is my general solution. Okay, now coming to the last one. The last one is cosec x equals to minus 2. Cosec x equals to minus 2. Cosec x equals to minus 2. Now, where all cosec will be negative, cosec is a reciprocal of sine, so it will be negative here and negative here, so it will be in third and fourth quadrant, right? So again, since I remember don't remember the value of cosec x when it is 2, I remember when sine x is equals to 2, so I remember when it is my sine x, sine of what is equal to 1 by 2, so my sine of pi by 6, 30 degree is 1 by 2. So my cosec of pi by 6 will be 2, right? So pi by 6 I got the value when it is 2. I just have to figure out when it will be negative. So my principal solution will be cosec of pi plus pi by 6. Why I did pi plus pi by 6? Because it has to be in this quadrant, and cosec pi plus pi by 6 will return me cos pi by 6, and this will be negative in this quadrant. And then second one would be my cosec of 2 pi minus pi by 6. So what I did is I just went to this full circle and then come back here pi by 6. So in this quadrant anyways my sine would be sine theta and cosec theta would be negative. So x would be pi plus pi by 6 is 7 pi by 6, and this is 7 to 12, and this is gonna be 11 pi by 6. Now these are my principal solutions, right? Principal solutions. Given my principal solution, I can find out general solution because cosec will follow sine. So here as well it will be what, n pi plus minus 1 to the power n, and sine pi by 6. So this is where n is element of z. So this is going to be my general solution. Alright. So yeah, this is how we do it when you remember these three things, right? When you remember these three things, when sin x equals to sin y, then what will be your general solution? When cos x equals to cos y, what is the general solution? And then tan x equals to tan y, what is the general solution? Then it is easier to do. Otherwise as well, you just have to look at your principal solutions and then try to come up with a general solution, because you know that when the values of various entities repeat, right? Tan x repeat after every pi, cot x repeat after every pi, whereas sin x, cosec x, sec x all repeat after 2 pi. So right, this is the last thing also you should remember, that when so tan and cot values repeat after pi, whereas sin, cos, cosec values repeat after 2 pi. Alright. So when you know that, then you will be able to derive this general solution easily. Otherwise, as I said, just remember the formula, remember the theorem, and you will be good. Alright. So yeah, with this we are done with 1, 2, 3, 4 questions of exercise 3.4. If you have any question, please ask me in the comment section below and I'll be happy to answer. Thank you so much for watching this. We are going to discuss problem number 5, 6, 7 of exercise 3.4 chapter 3, which is part of trigonometric functions. In previous lectures we have already covered exercise 3.3 and some problems of 3.4 exercise as well. In today's lecture we will start with problem number 5, and problem number 5 to 9 you've been asked to find the general solution of each of the following equations. Alright, so you have been given some equation, you have to solve and find the general equation of it. So again our method would remain the same. We will remember the concept and we will apply those concepts over here. So our concepts remain the same, whatever we had done in the previous exercise. So these three simple formulas we have to remember. When my sin x equals to sin y, then my general solution becomes x equals to n pi plus minus 1 to the power n into y, and when it is cos x equals to cos y, then my x becomes 2n pi plus minus y, and the third one is when tan x equals to tan y, right? Then your x becomes what? Your x becomes n pi plus y. Alright. So these are some of the formulae you have to remember, and then finally there are two more, and I hope you already know it, but still we will do it. So one is, say if in this special case of it, then sin x equals to 0, right? Which means it is either sine of 0 or sine of pi, right? So any multiple of pi would be 0. So in this case, my general equation generally is written as x equals to n pi, which is a special case. If you put it over here, you can see, right? It's n pi plus minus 1 to the power n into 0, right? So this is n pi anyhow, right? So x equals to n pi is 1, and then second one we got to remember is when cos x equals to 0, this means that it's an odd multiple of pi by 2, right? So first of all, this will be cos of pi by 2, then it will also be equal to cos of 3 pi by 2, and so on and so forth, right? So in this case, we can just simply write x equals to 2n plus 1 into pi by 2, right? Why? Because you see that these are odd multiples of pi by 2, right? But even if you write it like this, which we have learned, x equals to 2n pi plus minus pi by 2, if you had written like this, right? And this is also okay to write like this, but it's much better to write it in this format than the other one, right? So Hope this part is clear to you. If not, just write me in the comment section below and I'll be happy to answer your questions. Alright, now let's move on to the actual problem. My first problem is this cos 4x equals to cos of 2x. Alright, what I can do is I can write it like cos of 4x and then I can bring cos 2x on this side. So this becomes cos of 2x. Now I also know the formula of cos c minus cos d. This will become minus of 2 of sine of c plus d by 2, which is nothing but 4x plus 2x by 2 into sine of c minus d by 2, which is nothing but 4x minus 2x by 2 equals to 0. Which formula I have used? I have used this formula, cos of c plus cos of c minus cos of d, alright, which is nothing but minus of 2 of sine of c plus d by 2 into sine of c minus d by 2, alright. This is the formula I have used. Now, when you look at this expression, you can send 2 on the other side and this becomes sine of 4x plus 2x by 2 is 3x, 6x by 2, right? 4x minus 2x by 2 is sine x, right? Equals to 0. Now in this case, either sine 3x is 0 or sine x is 0. So I can write either sine 3x is 0 or sine x is 0. Why? Because if this is becoming 0, this means that one of these quantity is 0, right? So either sine 3x is 0 or sine x is 0. Alright. Now solve these two separately. We have just concluded that if sine 3x equals to 0, I can just write it as sine 3x equals to sine of n pi, right? Similarly, I can write it sine of x equals to sine of n pi as well, and x equals to n pi here, and in this case 3x is equals to n pi, so x equals to n pi by 3. So what has happened here is I have got two solutions of x. One is n pi by 3 or second is n pi. So we'll have to write it like this. So x equals to what? X equals to n pi by 3 or n pi. Alright. If you have any issue of understanding how this 3x equals to n pi we have got, you can just look at what I have done over here. When sin x equals to 0, we just write it like this, n pi plus minus 1 to the power 0, right? Sin x equals to 0. And this is what we will get over here, right? And so that's the reason whenever we get something like this, we just simply write this is equal to n pi and this is what we get. Alright, hope this is clear. Now let's go on to the next problem. What is my next problem? My next problem has got cos 3x plus cos x and then that is minus cos of 2x equals to 0. So I can see that there are two terms in summation and one is in negation, right? Let's try to solve the part in the summation and see what we get, right? And actually, when you look at this problem closely, when I look at this part, right, what I see is that if I try to solve it, this is cos c plus cos d, right? And what is the formula for cos c plus cos d? My formula for cos c plus cos d is 2 of cos of c plus d by 2 into cos of c minus d by 2. And what will be my c plus d by 2 here will be 3x plus 2x by 2. And then the other one will be 3x minus x by 2. So in that case, what will happen that I will be able to take out cos 2x common and then again I will be able to write it in the factor of 2 things, right? So that's the reason I will start with this. There is no harm if you start with cos 3x minus cos 2x also, right? But let's start with the one which I had mentioned. So I will take what? I will take cos 3x plus cos x minus cos 2x, right? Equals to 0, not LHS, we don't have to prove, but rather we are trying to solve this equation, right? So now I'll take this and this together, so I'll say 2 of cos of c plus d by 2, which is nothing but 3x plus x by 2 into cos of 3x minus x by 2, c minus d by 2, right? And this minus cos 2x will be minus 2x itself, right? Now 2 of cos 3x plus x by 2, which will become what? 4x by 2, which will become 2x, cos of 2x, and this is 3x minus x by 2, which will become what? It will become 3x minus x by 2, which will be 2x by 2, right? which will be cos of x. Alright, so this is cos of x, and then I'll have cos of 2x as well. I will have cos of 2x as well, right? So what I'll do is I can just take this cos 2x common. When I take cos 2x common, what will I left with? I'll be left with root 2 of cos of x minus 1 equals to 0, right? So now you can see that this is again a product of two things, right? And we know that when there is like the product of two things is 0, then one of these will be 0, right? So from here what I can derive is either cos 2x is 0 or your 2 cos x minus 1 is 0, right? Which is 2 cos x minus 1 is 0, right? This is this of this, right? And we have just done it in the previous slide that cos 2x when cos 2x equals to 0, we have done it in the previous slide that when cos 2x equals to 0, what will be the value? You know that when such thing happens, then 2x would become what? Or rather, let's take two steps. So this will be cos 2x would be what? Cos 2x would be cos of 2n plus 1 into pi by 2, right? Why this happens? Because it's an odd multiple of pi by 2, and then odd multiple of pi by 2 is always 0, right? So with this, what we get here on the left side is, we get 2x is nothing but 2n plus 1 into pi by 2, right? So this means that what we get x equals to what? 2n plus 1 into pi by 4, isn't it? So this is what we got it, right? Now on the other side we have got 2 cos x plus 2 1. This means that cos x plus 2 1 by 2, and when will be cos x 1 by 2 in positive? When we are in the first quadrant or the fourth quadrant, right? So either here in first quadrant or the fourth quadrant, here the cos would be positive. So when is my cos x equals to 1 by 2? When it is cos of pi by 3, or it's cos of minus pi by 3, right? In either case, it will be either this way or that way, right? Either pi by this theta or this minus theta, right? If that being the case, we know our general solution. We take this the first one, and x becomes what? 2n pi plus minus pi by 3, and where n is element of z, here as well n is element of z, right? So what we have got finally is x equals to what? 1 is 2n plus 1 into pi by 4, right? What we have got? First one is 2n plus 1 into pi by 4, or we have got 2n pi plus minus pi by 3. Alright, so these are the two solutions we have got, right? Let's move on to the third question. What's my third question? My third question is having sin 2x plus cos x equals to 0. So in just like in all other previous cases, we look at the expression and try to reduce it to some expression wherein it is a combination of 1 and 2, so that we can get either this as 0 or this as 0, and then we'll be able to solve it. So we will do the same thing here. While what we'll do is sin 2x plus cos x equals to 0. We know that sin 2x is nothing but 2 of sin of x into cos of x, right? And then cos of x is cos of x, we'll keep it as is. And then we are able to again take the cos x out as common. Then we are left with 2 sin x plus 1. So it's again reduced to 2 products, right? So alright, this is reduced to 2 products, right? So what will happen? Either cos x is 0 or this part is 0, alright? I think you can understand this part after following the third question, right? So cos x, either cos x equals to 0 or 2 sin x plus 1 is equal to 0, alright? And in this case, we know that when cos x equals to 0, we can just simply write x equals to 2n plus 1 into pi by 2. Simply, this is my general solution. And the other one, let's try to solve it. When 2 sin x plus 1 equals to 0, then what will be my 2 sin x? My 2 sin x is nothing but minus 1. And sin x will be what? Sin x will be minus 1 by 2. Alright. Now, my sin x is coming in negative. So, where all sin x is negative? In third quadrant and fourth quadrant. Right. So, if you know the value, I can just write, so I can just write minus 1 by 2 as sine of pi plus pi by 6. So we know that sine pi plus pi by 6 is in third quadrant, and sine pi by 6 will be 1 by 2, but when it comes out it will be again negative of minus 1 by 2. Or I can just go on the fourth quadrant and write, I can just write 2 pi minus pi by 6, both of these will be the values, but I will work with the first one itself because that's how we derive the general solution. So my sin x is becoming, let's sum it up, so this will become 6 pi plus pi, this will be 7 pi by 6, and this will be basically what, 6 to 12 minus pi, 11 pi by 6. So given this sine of this and sine of this, we know that my general solution will be x equals to n pi plus minus 1 to the power n, and I can write 7 pi by 6, the first value I will take. So now I've got two values, so I can write the answer as x is equals to 2n plus 1 into pi by 2. This is my first one, right? And then I can write or x equals to, this is the one, n pi plus minus 1 to the power n into 7 pi by 6. Alright. So yeah, these are the answers, and in all three equations what we have done is we have tried to reduce the expression into some product of two or more functions, and once we have got that, we have just equated each of them to 0 and then got the value. So in all these problems what you will get over here is that even if you put the value of this x equals to 2n plus 1 into pi by 2 in this equation, when you put this value over here, you will start getting 0. So let's do that and see one of the examples. So either this or this, right? So I take what? So I have to calculate the expression sine of 2x plus cos of x, right? And I take this value, right? So what will this become? Sine of 2 into 2n plus 1 into pi by 2, right? 2 will cancel out, plus cos of 2n plus 1 into pi by 2, right? Now this expression is what? This one has become sine of 2n plus 1 into pi, and this one has become plus cos of 2n plus 1 into pi by 2. I know that any multiple of pi would be 0, this will be 0, and same way cos of 2n plus 1 into pi by 2, this is an odd multiple of pi by 2, so this will also be 0, so cos is 0 plus 0. Again, when you put this value over here, we will get the same result. So yeah, this is what we do when we are trying to find the general solution of an equation. We try working with this system wherein you try to reduce the expression to two products and then get the values. Alright, hope everything is clear. If not, please do ask me questions in the comment section below, and I'll be happy to answer your questions. Thank you for watching. I'm going to discuss problem number 8 and 9 of chapter 3rd and exercise 3.4. And that is part of our trigonometric function exercise. So we have already discussed quite a few problems, that is 3.2, 3.3, 3.4 exercise, and in 3.4 itself we have discussed a lot of problems here already. And generally when we start, we discuss about the theorem or the concept behind the problem, and then we start working with the problem. Alright, so in today's lecture we are going to discuss problem number 8 and as I mentioned. So whatever we require in these questions, we will first write those formulae and then start working with the problem. Alright, so this is my first problem, and to start with the first problem, I will just go back and remember my theorems. So if we have to find out, of course, the general solution of this. So we know that if sin x equals to sin y, then my general solution it becomes x equals to n pi plus minus 1 to the power n into y. When it is cos x equals to cos y, then it becomes x equals to 2n pi plus minus y, and when it is tan x equals to tan y, then my general solution becomes x equals to n pi, and this is plus y. Alright, so this is my first, this is my second theorem, and this is my third theorem. Alright, so we are primarily going to make use of these, alright. And even if you don't remember this formula, as I mentioned earlier as well, you can still work with the principal solution and look at the pattern, and then yourself you can write the general solution. So anyways, if you know that these formulae are derived using the observation of the general solution, of the principal solution, sorry, and that's how we will do it, alright. So let's start with the first problem. So our first problem is saying sec square x sec plus 2x plus to 1 minus tan 2x, alright. We also know a formula which is this, right, which is sec square theta minus tan square theta equals to 1. So when I see this sec square over here, I know that there is some formula to be applied, and then I'll make use of that formula. So what is my formula going to be? Sec square 2x would become 1 plus tan square 2x, right? Because sec square theta is equals to 1 plus tan square theta, because sec square theta minus tan square theta is 1, right? And this will become 1 minus tan 2x. I can cancel out 1 and bring tan 2x on the other side. So this will become tan square 2x plus tan of 2x equals to 0. And if I take tan 2x common from here, then again it will reduce to tan 2x plus 1, and this will reduce to a product of two numbers, 1 and 2, right? And we know that when such case arise, when product of two numbers or functions are 0, so individually one of them could be 0 or both of them simultaneously can be 0, right? So when such case arise, what we write? We write either tan 2x equals to 0 or tan of 2x plus 1 equals to 0. So when tan 2x is 0, we know that in such case, similarly we have this 2x, we can write tan 2x equals to tan of n pi, just like sin theta. We know that whenever it's a multiple of pi, tan theta's value is 0. This implies 2x is equals to n pi. This implies x equals to n pi by 2 in first case. Look at the second one, wherein my tan 2x is equals to minus 1. Alright. Now you got to look at where my tan theta would be negative. When you look at the coordinate system, you see first, second, third and fourth. You have tan theta negative in second quadrant and in fourth quadrant. It is positive in third as well as in first, right? So given this tan 2x equals to minus 1, we know that it has to be either in second quadrant or fourth quadrant. So what I can write here is tan 2x equals to, one of the values would be tan of pi minus pi by 4 or tan of 2 pi minus pi by 4. So what I've done over here is, I as well know this part as it, right? Tan of pi minus theta is minus of tan theta, and I as well know this tan of 2 pi minus theta is gonna be minus of tan theta. So this is gonna be my even multiple of pi, so tan will remain in tan, and then since pi minus theta is falling in second quadrant, so it will become negative, and this will become negative because it is falling in fourth quadrant. So right, so what we have got here is 2x equals to pi minus pi by 4 is 3 pi by 4, and then this is 4 to the 8 minus pi 7 pi by 4, right? So given this, I can write 2x equals to, my general solution will be n pi plus 3 pi by 4, right? Given this, I can write x plus to n pi by 2 plus 3 pi by 4 or 3 pi by 8, because 2 will go and divide, so 4 into 2 will be 8. So with these two, what we have got is x plus to n pi by 2, and what we have got here is, the second solution is x equals to n pi by 2 and plus 3 pi by 8, right? So we have to put it or. So either this is true or this is true. Alright. So this is what would be your general solution. Okay, so let's move on to the next problem. So my next problem has got sin x plus sin 3x plus sin 5x equals to 0. So looking at this, I again realize that I may have to make use of formula sin c plus sin d, right? And if you don't know the formula, we'll just try to remember it. So my sin c plus sin d would be what? 2 of sin c plus d by 2 into cos of c minus d by 2. Alright. Now, we know that this is sin c plus d, but which one to take, right? It's a question, right? And when you look at again closely, when you look at this, when you put c equals to x and d equals to 5x, then your c plus d by 2 will become what? 3x, right? And this is what is available here as well. So, instead of putting sin x plus sin 3x together, I might want to put these two together. Why? Because I am looking at sin c plus d by 2 becoming sin 3x, and I might be able to take that common, right? And as you know, what we are trying to do to this expression is, we want to make it as a product of two functions, we could call it, and then we will equate each of them separately to 0. P1 equals to 0 and P2 equals to 0. Alright. So let's do that. So we'll put sin x plus sin 5x together, and then we'll keep sin 3x separately, and then this is equal to 0. Now sin c plus sin d, we'll put 2 into sin of c plus d by 2 into cos of c minus d by 2. Alright. And then my sin 3x remains as this, sin 3x is sin 3x. Now simplify this, x plus 5x by 2, this will become 6x by 2, and that will become what? 6x by 2 will become what? 3x, right? So now my 2 of sin of 3x into x minus 5x will become minus 4x, and minus 4x by 2 will be minus 2x. So cos of minus 2x plus sin of 3x equals to 0. Now I can take sin 3x common, right? So I'll take sin 3x as common, and now again my expression is like 2 of cos. Now we also know that cos of minus theta is equals to cos theta, right? So we'll use this formula. So cos of minus 2x will be cos of 2x simply, and then here when I take it sin 3x common, so 1 remains, so this is 0, right? Now this implies either sin 3x is 0 or my 2 cos 2x plus 1 equals to 0. These two cases arise, and when this is the case, we know that 3x is equals to n pi. Directly I can write, I have been doing it, so I am just writing, because I could have written sin 3x equals to sin 3x equals to sin n pi, and then equated 3x equals to n pi, but I am just going in one step. So x equals to n pi by 3 in one of these cases. In the other case, we have got 2 cos 2x plus 1 equals to 0. This means 2 cos 2x equals to minus 1. This means cos of 2x equals to minus 1 by 2. Alright. Now we know that cos theta is negative in which quadrant? In second and third quadrant, my cos theta is negative, right? So again, just to get the value, what I will do is, I can write cos of 2x equals to cos of pi minus pi by 3, and then the second one will be cos of pi plus pi by 3. Both the cases, basically cos of pi plus theta is equals to minus cos theta, and cos of pi minus theta is also minus cos theta, right? You know that? So given this, cos of 2x equals to, first one is cos of 3 pi minus pi by 3 will be cos 2 pi by 3, right? Or cos of 3 pi plus pi by 3 is 4 pi by 3, alright. Given this, we can write the general solution as 2x is equals to 2n pi plus minus 2 pi by 3, right? Given this, we can as well write x equals to n pi plus minus pi by 3, alright? Because I am just dividing it by 2 altogether, so 2 cancels out, so I will be left with this. Now with both of these together, I can write x equals to n pi by 3 or x equals to n pi plus minus pi by 3, and don't forget to write where n is element of z. I might have missed in the other one as well, which you should not be doing. You should write this n is element of z. It means that n can take values negative, positive, 0, all that, and in either case we know that since you move in this circle, you move in this direction or this direction, right, you will be able to get the same value. So that's why we put it as n is element of z. With these two questions, we are done with exercise 3.4, right? Now we will be doing miscellaneous exercise in the next video. Thank you for watching this video. If you have any questions, please ask me in the comment section below. Have a nice day.